Assalamu alaikum students, unit number 7, introduction to trigonometry, and we'll finish the exercise 7.1 in the last lesson, and today we will start exercise 7.2. And very little work for exercise 7.2 we have to do is some new formulas to be introduced, and the questions that you have to solve for the smart syllabus, only a few questions. Question number 1, second part, question number 3, first part, and question number 5 and 6. So not lots of working to be done in this exercise, and the formula to be used here is sector of a circle. A part of the circumference of a circle is an arc. You have studied this definition in chapter number 9 as well. So a little theory and a formula, and then we'll start the exercise. So a sector, a part of a circle, a part of circumference of a circle is called arc. For example, if this is a circle, then its any portion is called arc. Also, a part of the circle bounded by an arc and a chord and arc form a segment. You know very well about this in chapter 9. And then a part of the circle bounded by two radii and their corresponding arc is called sector. So this is the only review of the few definition you know very well. And now we are going to find the relationship between the arc length, the radius, and the angles subtended at the center of the circle. To establish the rule L equal to r theta, where r is the radius of the circle, L is the length of the circular arc, and theta the central angle measured in radians. Let an arc AB, see the diagram, denoted by L, subtend an angle theta. Very clear diagram. You can see an arc AB subtend an angle theta at the center of the circle. It is a fact of plane geometry that measure of central angle of the arc of a circle are proportional to the length of their arcs. Measure of the central angle are proportional to the arcs. Then you can see measurement angle AOB. The measurement angle AOB is proportional to measurement angle AOC. Okay, where we'll discuss about the arc length, the radian and degree. We have studied these two definitions. The angle subtended at the center of the circle by an arc is called 1 degree. The angle subtended at the center of the circle by an arc such that the arc length is equal to the radius of the circle. The concept same is used here. It means the angle AOB is proportional to the angle AOC. It means they are equal to their corresponding arcs, measurement AB and measurement AC. What is AB is L. What is AC? The second arc, we name it as R, and the angle, first one, angle at O is theta, and angle at AOC is 1 radian. So here we have two definitions implemented, and also the result that we obtained, the relationship between the angle at the subtender of the circle by an arc is called 1 degree. The angle subtended at the center of the circle by an arc whose length is equal to the radius of the circle. Therefore, this length is r. Now, this is theta radian. It is 1 radian. Theta, this will be measurement side AB equal to L and measurement side BC equal to R. So 1 equal to 1. It means L over R equal to theta, and from where we deduce the formula that arc length, radius and the angle subtended at the center of the circle are related as L equal to R theta. This just we need to know this formula, and now let's apply it in the questions. The question number 1, second part. Question 1 is find theta when the second part L is equal to 4.5 centimeter and R is equal to 2.5 centimeter. In the solution you will write, we know that the arc length, the radius and the angle are related as L is equal to R theta. We have to find the value of theta, so eliminate this theta. R is multiplying with theta, on the other side it will divide L over R. The arc length 4.5 divided by the radius 2.5. when you divide both of them you will find the angle, which is equal to theta 1.8 radian. So this is a very little working in these questions. And similarly, its first part not is the part of ALP. Question number 2 is not the part of ALP. Question number 3 and its first part, given that find R when L equal 4 centimeter and theta equal 1 over 4 radian. Again, in the solution we know that the arc length, the radius and the angle are related as L equal R theta. We have to find the value of R, so this theta is multiplying here, on the other side it will divide and we'll find that answer. Yes, we have to find the R equal L over theta. Putting the value of L and R, L equal to 4, theta equal 1 by 4, and this 1 by 4 when become 4 into 4, it is 16 centimeter. Question number 5, very simple parts. There is nothing to do much here, just a simple formula. In the question number 5, it is given, in a circle of radius 10 meter, find the distance traveled by a moving point on this circle if the point makes 3.5 revolution, and the hint is 3.5 revolution means 7 pi. In a circle of radius 10, it means the value of R equal 10 meter. Find the distance traveled by a moving point. Moving point, it means arc length. Arc length we'll have to find, and if the points make 3.5 revolution, that will be the revolution, mean a complete revolution you know is equal to 2 pi. Circumference of the circle is equal to 2 pi, and 3.5 revolution, it means 3.5 multiplied by 2 pi will be 7 pi, and we'll have to find the value of L here. The statement, find the, in a circular radius, circular region of radius 10 meter. Solution, in a circular region of radius 10 meter, we will write in the solution that number of revolutions, first radius is equal to R is equal to 10 meter, and number of revolution that a point is is 3.5. Angle of one revolution, angle of is the one revolution. For example, if we have a circle, then one revolution will start from is equal 2 pi. 2 pi r is called circumference of the circle, but one revolution mean a complete angle. So angle of 3.5 revolution will be 3.5 multiplied by 2 pi. It is 7 pi, which will be the angle. We'll have to find the arc length L equal r theta. R is 10 and 10 multiplied by 7 pi. Now put these values 10 multiplied by 7, and when you press shift 10, pi will appear. It will be 220 meters. Now let's move on to the last part of this exercise. The last part is question number 6. A simple statement. What is the circular measure of the angle between the hands of a watch at 3 o'clock? It means when it is 3 o'clock on the clock, what will be the circular measure? What will be the circular measure? It means कि अगर we have a circular watch, then at 3 o'clock what should be the angle? Very simple, 3, 6, 9, 12. It will be 90 degree. Now let's write it in your wording. Solution question number 6. What will be the circular measure of the angle between the hands of the watch at 3 o'clock? First, if we have a watch, circular measure, then at 3, you know, and 12. Completely you can see 1, 2, 3, 4. 4 right angle will be formed. In the solution you will write at 3 o'clock the minute hand will be at 12. Will be at 12 and our hand will be at 3. Will be at 3. So the angle between the hands of a watch will be 1/4 of the central of the angle. So angle equal 1/4 of total central angle. Total central angle. You know that angle at the center when of a watch is 360. It means 1/4 360 mean it will be 2 pi radian, where pi equal 180. It is pi over 2 radian, that is 90. So this was the exercise 7.2. Very simple and easy parts in the ALP syllabus. I hope you understand that. Thank you so much.